Hello, Science Alliance. Hello, I am Lara. This is Theory of Science. This is the first lesson back after the summer holidays. So if you're watching live and you're a regular, hello, welcome back. And if you're watching live and you're a newbie, you found me. Brilliant. I've been doing this for 5 years. And I'm excited because we've got 8 lessons. It's a long term, 8 oceans lessons stretching ahead of us and 3 activities to do this lesson. So we better crack on, actually. I thought we'd start these oceans lessons at the very beginning. That's quite a theory of science thing to do. We'll look at why water is important, and then we'll look at why planet Earth has oceans, and then I feel like we'll be a bit more appreciative when we start learning about all the different animals that live in the oceans and all that stuff. Okay, so the first thing you need to do is, if you're doing the activity with me, you might not be, and that's totally fine. Can you get a blob of oil and put it onto a plate, and get a blob of water and put it onto a plate? Now, like I say, you're very clever to come to this lesson because I've already taught this lesson twice on Facebook. And it was really annoying me on Facebook that I couldn't get a good angle on my plate because it had a lip. So I'm using a flat thing today. Here we go. No, it's good, isn't it? So can you tell me, if you're not doing it, that's fine, just look at mine. The activities will get more exciting than this. But first of all, can you just observe your blob of water and your blob of oil, please? Just observe them. It's a very scientific thing to do. This is the oil, and this is the water on the left. You see any differences? If I was a good scientist, I'd have made them both exactly the same size, and I have not done that, but they were pretty much the same size. What do you see? Yeah, see? Can you see that one is more blobby than the other? Scientific term. The water's more, it's just a bit more bouffant, right? The oil is quite flat. So this is because you might have heard of water called H2O, have you? You know water? H2O, water. So water's called H2O because it is made of 2 hydrogen particles connected to 1 oxygen particle. This isn't a chemistry lesson. Some of you are going to know about atoms and some of you aren't, so I'm not going to make it too complicated. But basically, water particles are very special because atoms like hydrogen and oxygen, they're made of positive and negative things. And on a water particle, the oxygen nicks the negativity from the hydrogens. So basically what ends up happening is you've got the hydrogen particles are a little bit more positive and the oxygen particle is a little bit more negative. And negative and positive things are attracted to each other. So they're sort of like magnets. They all end up lining up like magnets, which is why if you've ever looked carefully at water, you'll notice it's kind of got a skin, right? Because that is basically just a film of little water particle magnets all joined up together, keeping the water in shape. It's called water surface tension, whereas oil, you can see it, that it's not quite as sticky like that. So it's all splooshed out a bit more. Again, technical term. So I didn't really know this until I started researching this lesson. I never thought about it, but one of the reasons why water is amazing for life existing, like we don't know of any life, any living thing, fungus, bacteria, animal, plant, anything that can live without water. And one of the reasons is because water is sticky. It can go up the stems of plants, right? So it gets drawn up things. Yeah, it's very handy. It's stickiness. So it gets drawn up the stems of plants, and obviously plants kind of produce oxygen, which a lot of things breathe in, and also plants use water to make their sugars, which basically everything else on the planet eats. So yeah, water, great, because sticky, because plants use it to make their food. The other reason it's really good, here's another thing that I hadn't really thought about. This is an activity we've never done on Theory of Science. If you've got a tiny little pinch of salt or sugar, can you put it into your water and put it into your oil and tell me what you see again? Or tell me what you think you're going to see. When I do it, I'm going to put a pinch of sugar into my water and a pinch of sugar into my oil. What are we going to see? Predictions, please. Again, with the very, very poor scientific practice, I should be using exactly the same size pinch of sugar, but you're just going to have to like watch and judge harshly. That's not too bad, is it? Okay, and then I'm going to get a stir and spoon it. What are we going to see? What are we going to see? Now, you might have a very good idea of what you're going to see with the water because you might have experienced this in real life. You might know people who put sugar in tea. They're wrong. That's a terrible thing to do. Ugh, but you probably know what happens when you mix sugar or salt into water if you do it enough. it sort of disappears, right? She says, clearly not having made it disappear. So this is called dissolving. When stuff can get mixed up with something else and sort of seem to disappear, it's called dissolving. The sugar particles have all broken up and sort of interspersed throughout the water. Look, they really have disappeared, haven't they? Completely disappeared. With oil, this doesn't happen. And again, I'd never thought about why this makes water so brilliant for keeping things alive, so brilliant for life. Like, I could do this with this sugar and oil all day long, and if anything, it's just getting worse. It's just all clumping together. So water is really good at dissolving stuff. It's really good at making stuff break up and disappear in it, whereas oil is not so great. So yeah, I hadn't thought about this until I planned this lesson. Chemical reactions are happening all over your body all the time. All life needs chemical reactions to happen. And what chemical reactions are particles like popping apart, moving around, combining in different ways. So you need to be able to dissolve in things. Particles need to dissolve in stuff to do their chemical reacting. So all the cells in your body got water in them. That's where the chemical reactions happen. So you couldn't exist with oil in yourself for loads of reasons. But yeah, that's another reason why water is really good for life, because it lets things dissolve in it, so that makes chemical reactions happen. Right. The other, again, I didn't know this until I planned this lesson. The other reason why water is amazing for life is because it's liquid at a lot of temperatures. So like if you get a metal spoon or something, or your metal baking tray, if you've got something metal with you, you're at room temperature right now. Yeah, that's good, isn't it? Oh yeah. You're at room temperature, and these metal particles are really firmly bonded together. Like the thing is solid. You'd have to put loads of energy into your metal baking tray before it melted into a liquid. So much. You would be dead, wouldn't you, by the time this got hot enough that it melted. It'd be well hotter than your oven. Whereas water, if you've got some water with you, water is a liquid at room temperature. You'd have to put loads more into that water before it boiled into a gas. So yeah, the reason why water is really good for life is that it stays a liquid for a lot of temperatures. I did you a little timeline. Have a look at this. So there is another sort of particle that is also really good at dissolving stuff. It's called methane. We'll talk about it actually a little bit later. But methane, it's a gas anywhere over minus 160 degrees. It's a gas. Its particles are just not very good at bonding together. So it likes to be a gas. It likes to fly around on its own. Only when it gets even colder than minus 160 degrees does it turn into a liquid. And as soon as it gets to minus 182 degrees, it turns into a solid. So you've hardly got any time where methane is a liquid. So if you lived on like methane land, then every time it got a little bit warmer than minus 160 degrees, you would boil to death, which isn't good. Whereas water, you might know, water only freezes at 0 degrees and it only boils at 100 degrees. So you've got a lot more room. You see what I mean? Yeah, is it? Anyway, right. Let's talk about how the solar system began and do another activity, because this is kind of tied into why water is good for life and why things like freeze and boil at different temperatures, okay? So, in the beginning of our solar system, before our solar system was born, there was just a cloud hanging in space. And this cloud had big heavy particles in it, like metal particles, particles that bond together really strongly, even when they're hot. So can you put some heavy stuff on your baking tray if you're doing this with me? If you're not doing it with me, you can just watch me. Like, why am I even doing this if you're all doing it? Someone's just got to watch me. So yeah, we've got a cloud, it's hanging in space, and it's got a lot of heavy particles in it. Because our solar system wasn't formed like right at the beginning of the Big Bang. So the Big Bang's already happened, stars are all around, they're burning, they're dying, and they are giving off loads of heavy particles like iron, nickel, all that sort of stuff. So we'll say that this is sort of particles of different metals, right? But there's also loads of light particles floating in this cloud. So if you've got any sort of herb or a sugar or salt would be all right, any spice, anything light. This is the stuff that's hanging in the cloud that is quite small particles, like hydrogen, which was formed in the Big Bang, helium, There's some oxygen in this cloud because that's formed in stars. So we've got hydrogen and we've got oxygen. So we've got water, which is also quite a light particle just floating around. Not as a liquid, just particles of water. Particles of hydrogen, helium, and all the heavy metal particles all swirling in this big cloud, right? Just floating in space. And then a star nearby dies, like supernova explosion. And this shockwave goes through this cloud of stuff. And it all starts swirling together. And 99% of that stuff forms the sun. So if you're doing this activity, I need you to imagine now that your face is the sun. Your head is the sun. You are over 99% of the stuff that was in this cloud. And the stuff on the baking tray is the less than 1% of stuff that was left over. Okay, so my head is the sun. Right, this is where I get really excited. I love it when stuff you've known for ages suddenly makes sense. So you're the sun, right? Your face is the sun. This is the rest of the stuff in the cloud that's left over. All of this stuff is going to form the planets, Mercury, Venus, Neptune, Mars, the asteroid belt, all of the comet, everything in our solar system. You're really hot. You're really, really hot. So what's going to happen to the particles right next to you? Right next to the newly born sun? Well, you're really hot, but the heavy particles in this cloud, yeah, like your ions and your nickels, they can still be solid even when it's really hot, right? So they're just going to still bond together to form solid things. So you could do that now. I'm going to do it. If you've got the tray, maybe make 4 piles. We'll explain why later if you can't see where this is going. Can you see where this is going? So I'm going to make 4 piles of heavy particles clumped together. There we go. The particles further away, they're not clumping together because they're cooler, right? Oh, well, I mean, anyway, I'll confuse you. The other thing that's happening, so the sun is very, very hot, so only the particles near the sun can clump together that are heavy. The light ones can't clump together because there's far too much energy here. The particles, they're all excited. They're all flying apart from each other. So the hydrogens and the heliums and the water, they're still just flying around. The other thing the sun is doing is, don't be rude, it's giving off solar wind. Okay, solar wind is just like loads of tiny little particles that the sun blasts off. So I want you to blow gently on your baking tray because that is what happened, and see what happens. I'll put you behind me so that you can experience the magic of this scientific model in action. Here we go. Here we go. So these are my little clumped up, they're the bigger particles, right, that have formed solids because they don't care about the sun being really hot. Blow on the baking tray and see what happens. Can you see where this is going? Oh, gasp! The light particles all got blasted away by the solar wind. And that's why, children, the planets nearest the sun are rocky. Because those are made of the heavy particles like your nickels and your ions that could clump together even though they were right next to the sun and the sun was really hot. They could become solids. Oh, if you came to my astronomy lesson, you knew that already, but it was years and years and years ago, so hopefully you'd forgotten. And the planets much further away from the sun, they're gassy. They're made of the particles like your hydrogen and your helium, bits of water particles that all got blasted away from the sun by the solar wind. It's good, isn't it? Now, there's an imaginary line here where the asteroid belt is actually, between Mars and Jupiter, where it's too cold for water to be a liquid, okay? Past that point, it's too cold for water just floating around in space to be a liquid. So Saturn, for example, has water in its rings, but it's ice because it's too cold. And some of the moons are icy as well, like Jupiter's moon, Europa here, is covered in ice. Do you want a closer look at Europa? Yeah, you do. Come on, NASA bothered to take a photo of it. Let's enjoy this. So Europa is one of Jupiter's moons. It is totally covered in ice. These brown lines are where it's cracked and then refrozen. And the white, bluey bit is basically purish water ice. That's good, isn't it? Right. I just did loads of talking and we did 2 activities. So I'm going to ask you a couple of questions now to see how much of that has stayed in your head. And then we'll move on to talk about why Earth actually has oceans. So yeah, some of you are like 5 and maybe haven't done any science before. And some of you will be 13 or 14 and also come to my IGCSE physics lessons and know a lot of this stuff. So I've given you some questions that they're going to exercise your brain, but they're sort of more straightforward. And I've given you some questions that I just don't think you're going to be able to answer. I mean, hopefully you can't. Those are for the people who are getting coffee. So here you go. First question, water is great at supporting life. It's so good at keeping things alive. Can you find the reasons why? If you went to my website and you downloaded the free optional printouts, then you can circle them on the sheet. If you didn't, doesn't matter, you're not missing anything. It's just on the screen here, so just have a look at them. Next question, the planets nearest the sun are... What are they? What are the planets nearest the sun? So you can choose from rocky, it freezes, it's great at dissolving things, gassy, it's sticky, it's liquid at a lot of temperatures. Why aren't Saturn's rings made of liquid water? Why are Saturn's rings not made of liquid water? Wait, why are they? Why aren't they? Why are they not made of liquid water? Saturn's rings. And the last question is like, just do 20 press-ups, basically, in your head. Liquid water is, in fact, found at the gassy planets. How can that be? Like, I literally just told you that you can't get liquid water near the gassy planets because it's too cold. So, but you can actually. So how can you tell me that? Explain that mystery, please. Oh yeah, and then I'm gonna gather my other bits because after this we're gonna make a cloud. Oh, possibly my favourite activity ever. Oh, I should say, if you're new, then you'll have noticed there's no comments on YouTube videos. But if you do have a Facebook account and you want to go to my Facebook page, then there's always a post at the top there when I'm live on YouTube saying, you can comment on this post if you're watching live. So if you want to go over to Facebook at some point during this lesson and leave me a little message at the top of my Facebook page on that post, and I will read it out in the end and say hello. But you totally don't have to. To be honest, if everyone did, we'd never get anything done. So if you can't access Facebook, then that's great for loads of reasons. It's the right answer. But if you can, go say hello. Do you know what? I'm just going to try and stay quiet so that you can get this question answered. Oh, thanks for all the likes. That's very nice. I will explain at the end of the lesson how you can't actually pay me for my job, which is how I am doing this. But likes are really nice as well. So the first question, why is water so great at supporting life? It could be just one answer, or it could be 2, it could be 3, it could be 4. I'm going to leave it up to you. And I've got, I don't know how many answers there actually are. I've got 3 answers to the last question. I'll give you like a few more seconds. And then we'll go through it. I do feel like I was talking at close to the speed of light when we were talking about why water's important for life. So this is sort of kind of for you to check if you've understood, but like I've put in the title, it's also very much for me to check that I've taught you anything, to check that I've taught you correctly. That's why coming to the YouTube lesson is the best idea, because on Facebook I've got comments. So I ask this question, and if they all go, no, we didn't get that bit, I can be like, oh, okay, I need to improve that bit for the YouTube lesson. Okay, let's go through it then. Water is so good at supporting life. Why is it? Well, partly it's really good at dissolving things. So that makes the chemical reactions able to happen that life needs to do, which is very good. Also, it's sticky, so it can go up the stems of plants and things like that. Also, it's liquid at a lot of temperatures, which is also really good. I didn't say it freezes because like everything turns into a solid, everything freezes if you get it cold enough. So that's not a sort of special thing that water can do. But if you put that, then, I mean, it is really handy for us to have ice on planet Earth as well. The planets nearest the sun are not gassy, they're rocky. There we go. Well done if you put that. The planets near the sun are rocky. Mercury, Venus, Earth and Mars. Why aren't Saturn's rings made of liquid water? Because it's too cold. I told you that. It's too cold for Saturn's rings to be liquid water. It hasn't got enough energy. The water is a solid. So how can it possibly be that you can find liquid in after the frost line? Well, it could be that it's trapped under a protected layer of ice. It could be that it has salt in it, because salt changes the temperature at which water will freeze. Or it could be that maybe the planets or whatever have got a lot of atmosphere, like loads of gas around them, and that squashes the oceans and keep it in place. Do you want to hear some real examples from our actual solar system? Yeah, you do. So Jupiter's biggest moons are called the Galilean moons because Galileo first saw them through a telescope in 1610. Here's Galileo Galilei saying, "You're so welcome." I said I wouldn't do the accent, but I've started. "I'm a delight to help, but no, really, I am ecstatic. This is just what people's faces looked like in the 1600s. He doesn't look very happy, but anyway, he's a great guy. Thank you for these moons, Galileo. So here's Europa. These are in order that they are from Jupiter. So the second moon, well, the first moon, Io, of the Galilean moons, it's very volcanic. It's got a lot going on under the surface, like a lot of action, a lot of forces pushing and pulling and squeezing. And Europa's the same. So we think that underneath all the ice of Europa, there might be a liquid ocean being warmed up by all those forces going on the inside. And there might be an ocean under Ganymede as well, which is very exciting because you need water for life, as far as we know, but you don't need oxygen for life. There are some things really deep down in our ocean that don't need oxygen to survive. So there could be, not like probably 20 armed aliens, but there could be teeny tiny little microscopic things living in the oceans of Europa and Ganymede. Oh, can you imagine? Let's look at some more moons. So another reason why liquid water could be on a planet is it could have some salt in it that stops it freezing, or a moon. But the other reason is it could have an atmosphere squashing it and keeping it in place. And that is the case on some of Saturn's moons. Titan has got lakes of methane, I know, which might support life. We're not entirely sure. We don't know of any living thing that can exist just using methane, but like I say, it is good at dissolving stuff. So it is possible that some living thing has evolved to use methane instead of water, but we don't know. But there might be in the lakes of Titan. There might be something. We're just not sure. Right, shall we do our third and final activity? Shall we make a cloud and talk about water on these rocky planets? Because are there oceans? Is there liquid water on Mercury, Venus, Earth or Mars? Well, Mercury, no, there's just not. No, it's too close to the sun. It's right next to that solar wind. The solar wind is blasting little Mercury so hard that Mercury doesn't have an atmosphere. It doesn't have any gas hanging around it. So any water on Mercury would just boil away straight away. It does have a tiny little bit of ice in the shadowy craters of it that aren't facing the sun. But no, there's no chance of oceans on Mercury. Venus, I've just put, nothing wants to be on Venus, not even water particles. Venus is famously surrounded by acidic clouds, very thick atmosphere. So it's really hot on Venus. The water would just boil away from the surface. But actually, we can't really get there because of all the acidic clouds. So, you know, don't speak too soon. But as far as we know, no, there's no ocean on Venus. Mars is very interesting because it used to have water on its surface. And then the water went away, and we're not entirely sure why. So here is, thank you NASA, actual photos of actual river valleys on Mars. So this is where a river used to flow on Mars. This other photo you can see really clearly, look, where rivers used to flow. And then, yeah, we're not, scientists are still arguing about why there is like some water on Mars, but it doesn't stick around. And there's lots of ice on it and under the surface, but something to do with the atmosphere, most of the water sort of disappeared. Right, our planet has got oceans. Let's have a look at why. We're going to make a cloud. To make a cloud, in fact, I'll show you this picture because that might help you. And then I'll do it for you. You put very, very hot water in a jar or a glass. Be really careful. Can you please get an adult? I better show you my face. Please get an adult to do this because we're using very hot water and we're also holding matches. So just get an adult to do it. If there's no adult with you and they haven't given you permission, just don't do it. Do it later. Show them later because it's amazing. They'll want to see it. But what I want the adults in the room to do is put very hot water in a glass. Be careful. Make sure it's not so hot that the glass cracks. And then you light a match and you hold it in the jar for a bit. And then you drop the match in. And then you put a plate with ice cubes on over the top. I'll do it in front of you to show you. Okay, so come down. Glass. Very hot water. Hopefully very hot water. Oh yeah, that's nice and hot. In fact, I hope it doesn't crack the glass. There we go. And then, yeah, you light a match. I'm sorry that it has to be a match. These are not actually as much of a household object as I kind of assumed that they were. But here we go. So this is the dangerous bit, children. Don't you do this yourself. You've got to hold the match in so that the glass gets a little bit smoky, yeah? I'll tell you why after. And then when you're happy that you've done that, then drop it in and immediately put a plate on top, okay? There we go. Whack a plate on the top and then put some ice cubes on. Phew. Now, when I lift the plate off in a sec, a cloud is going to come out. And some non-believers, some, intelligent, creative people who want to check everything's true, always say, Lara, that's just steam. So I'm going to prove to you that it isn't steam by doing the activity again badly. I'm just going to put hot water into a glass this time. I'm going to put a plate on top. And I'm going to show you that it's not the same. Right. Why have we done that? Well, let me explain. In fact, if you've still got your baking tray, we've got quite a good model for what is happening right here. Are you okay while doing that? I'm just going to chat at you. I'll hold the picture up maybe. I'll hold the picture up so that you can sort of be reminded of what you're supposed to be doing while I chat. Is that okay? Sorry, the writing's backwards. There, fixed it. So, if you've done this baking tray activity, you will have noticed that some light particles, like water particles, did get sort of mashed into the planets when we formed our solid planets at the beginning. There ended up being water trapped in Earth, and we don't really know why that is. Some scientists think that like meteorites pelted Earth and brought water with them, like from far out, frozen ice in the solar system got smashed onto Earth, and that's how Earth ended up with water. Some people think that the water was there already, but anyway, Earth ends up with water in its rocks. And then Earth just gets like bashed about because it's the very olden times, it's a very rough solar system, loads of stuff flies into Earth and Earth gets very hot. So it sort of settles, like the nickel and the iron end up in the centre of Earth. And a lot of the water particles escape. So the water particles come out and then Earth stops bashed around and Earth starts cooling down. And those water particles form clouds. Because how clouds work is, it's basically just water vapour, water particles that are getting so close together, there's so many of them, that they need something to stick onto so that they can become liquid or clouds. They won't just stick together on their own. So you've put a match in the jar because you want loads of water particles and you need to give them a little bit of dust to cling to. So the water particles that are surrounding Earth, they start clinging onto little bits of dust or whatever. Yeah, and they form clouds. And it starts raining and oceans form, and then water particles evaporate off the ocean and then come back down again, and we end up with a water cycle, which is what basically keeps us all alive now. So you could say clouds are like absolutely vital for our existence. Okay, are you ready? We're going to release the cloud. I'll release the one that I didn't put the match in first to try and prove to you that it doesn't work, and what we're looking at is not just steam. Okay, so you ready? Hope this doesn't work. Lift you up a bit so you can see. Okay. That wasn't bad actually, was it? Oh, poo. That does look a bit like a cloud. That's actually quite a nice cloud. Maybe there was some dust in the glass already because I had put a match in there before. Anyway, let's see if the one where we put a match is better. You ready? Here we go. Oh, much better. That's a proper cloud. Oh, isn't that gorgeous? Oh, honestly, I can't love this activity more. You get to make a cloud and then you get to set a cloud free. What is not joyous about that? So, just like on Earth, water particles filling the air, gathering together around little bits of dust and then forming clouds, and then obviously from clouds you get rain. And that's why, that's the long story of why it's only on our planet that oceans can exist and allow life to thrive. Woo! Right, chums, that is pretty much the end of the lesson, except we've got a little mystery word quiz for you because I know that you love those. So yeah, so we've got 7 more ocean lessons stretching ahead of us now. My cloud is still being released. This is so nice. Yeah, next week we're going to map the oceans, look at like how deep the ocean is, how wide the ocean is, look at where the seas are, what's the difference between an ocean and a sea. And then after that, we're going to do basically all the animal stuff that everyone really wants to know. But I thought it'd just help us to appreciate, before we start looking about like animals and how deep the ocean is. I feel like I will have a better appreciation now of all that stuff. Now I know how amazing it is that Earth has oceans in the first place. Right, we will do a mystery word quiz. I'll do my advert first, all right? Because I need to stop cringing about my advert, because if I don't tell you how I earn money, I don't earn any money, and then I can't do this job. So how this business model works is, it's so ridiculously good. I started streaming lessons for free in lockdown. I'm trained to teach physics actually to A-level. I'm a trained secondary school science teacher. I was just taking a break to raise my kids. I started streaming in lockdown, basically just for Facebook likes and glory. And then home educators were watching and they wanted me to carry on. So I said, okay, well, there's this website called Ko-fi that lets you just send people money for stuff, basically. So I set up a Ko-fi page and I said, if you want to support me with £5 a month, like if you can afford £5 a month, that'd be great. And then just, you all signed up, even though you didn't have to. So now this is my full-time job. It's my full-time job. Look at me. It's so good. So everything that I do is free. All of the lessons are free. Literally all of them. Like, I don't do any kind of private tuition. I don't do one-to-one tutoring or small Zoom classes with all my like physics teacher training. You are my students, that's it. So yeah, I stream a free all ages lesson like this. I stream an IGCSE physics lesson, which you should totally come to. It's free, just try it out. In the same way, both of those have got free printouts, which are on my website if you want to get those. They're optional. And I also do a Lego story show, which isn't a lesson, there aren't any printouts, it's just me in a ridiculous, awful costume, telling a Lego story show. We do an activity and we chat about a thing. It's Otters at 10:30 this morning, if you want to come to that on YouTube. And yeah, I just say, if you can pay me, if you are using me and you can afford £5 a month, then please support me on this website called Ko-fi. If you go to my About section on YouTube, which is where you are right now, then you will find a link to it in my About section. What I was going to say, oh yeah, I send you nice things if you sign up. So this is the only thing that people who pay me get that people who don't pay me don't get. Because obviously it costs me to print it out and post it. But I write a magazine called Theatre of Science Magazine imaginatively. And yeah, you get past issues when you sign up. So if you support me with £5 a month, you get this issue on mould at the moment, which comes with a home compostable plastic bag. It took me ages to find that. So you can make this little tray at the back, grow moulds, like different moulds on different foods, and then hopefully identify them. It's got a beautiful comic about how penicillin saved the world, not just because of one bloke. It's got a choose your own adventure. I haven't read it for a while, but you're a mould expert in a museum, and like you can get promoted or stuff sets on fire, I think, depending on what choices you make. I love writing Theory of Science magazine. It takes me forever. It doesn't come out very often. But if you sign up to support me, you get a past issue or two, and then you're on the list, basically. So whenever I've finally got a new one out, you'll just automatically get it posted to you. If you support me with £6 a month at the moment, you get the Time issue as well, which has got a sundial in the back, and another beautiful comic about a woman who sold time, some stuff about how Einstein's theory works, and how time zones work and all that stuff. Oh, and everyone who's supporting me also gets some rainbow glasses, because they're awesome. They make you see rainbows. They're really cool. Right, that's my ad. So thank you so much. This is literally all only possible because you don't have to pay me, but you are anyway. So hopefully £5 a month for you, for what I'm offering, is very good value. I mean, I know it is. Come on, it's good value. But £5 a month from everyone works up to a wage for me. Right, sorry. Now we'll do the mystery word quiz, and then I'll go over to my Facebook page to see who said hello. So I'm going to ask you 4 questions. You have to pick the letter that you think is the right answer. And then in the end, hopefully, you'll have a mystery word. And if you've got all the answers right, it'll be the correct mystery word. If you haven't, well, hopefully you'll still have a mystery word. Hopefully I worked it out like that. Okay, here we go. So, first question. Water supports life because it's good at... If you think water supports life because it's good at dissolving things, then write an M. That's the first letter of the mystery word. If you think water supports life because it's good at orbiting planets, write an H. And if you think water supports life because it's good at dissolving into things, then write an L, okay? Why is water good at supporting life? Is it good because it dissolves things? Write an M. Is it good because it orbits planets? Write an H. Is it good because it dissolves into things? Write an L. Next letter of our mystery word. There used to be rivers on... I think this is quite tough. You really have to be listening, didn't you? The whole way through. And there were a lot of words in this lesson. Did there used to be rivers on Jupiter's moon, Europa? Write an E. Did there used to be rivers on Mars? Write an O. Did there used to be rivers on Mercury? Write an E. Can I move on? Which one of those did there used to be rivers on? Mercury, E, Mars, or Jupiter's moon, Europa? Eh. Okay, let's go. In which of these is liquid water definitely not found? If you think that liquid water is definitely not found on Earth, no way, write a W. If you think liquid water is definitely not found on Europa, write an N. If you think it's not found on Ganymede, for sure, write an O. And if you think it's certainly not found in Saturn's rings, then write an A. So this is the third letter of your mystery word. Is it W for Earth? There's no liquid water on Earth. If it's N for Europa, if it's O for Ganymede, or if it's A for there's no liquid water in Saturn's rings. What's on that? And finally, sorry, Europa. The inner planets are rocky because when our solar system formed, that's where the heavy particles happen to be. Write a T. If you think the inner planets are rocky because when our solar system formed, that the sun blew the heavy particles, write a D. And if you think the inner planets are rocky because it was so hot that only the heavy particles could become solid, then write an N. I just got new coffee support, thank you so much. The inner planets are rocky because when our solar system formed, that's where the heavy particles happen to be, write a T. That's where the sun blew the heavy particles, write a D. It was so hot that only the heavy particles could be solid, write an N. Right, you ready for the answers? Water supports life because it's very good at dissolving things. So the first letter was an M. There used to be rivers on Mars. There used to be rivers on Mars. There might well be liquid water trapped under the ice of Europa. There's a tiny little bit of ice in the craters of Mercury that aren't being blasted by the solar wind or heated up too much. Mars did used to have rivers. In which of these is liquid water definitely not found? It is Saturn's rings. No, it's too cold out there. So Saturn's rings have a lot of water, but it's all water ice, icy water. The inner planets are rocky because when our solar system formed, it was so hot that only the heavy particles could clump together and become solids. So the mystery word was moon, because I thought it was too obvious to make it moon, wasn't it? So if you got the mystery word moan, well done. If you didn't get the mystery word moan, you might be moaning about that. So you kind of still got the mystery word. Do you like what I did there? All right, let's go over to Facebook and find out if anyone has said hello. And then after that, I've got to go and reset up my Otters Lego story. So don't let me get too distracted, okay? Because you're very good at asking lots of very good questions. Plus, there's a lot of people watching live. Loads. I shouldn't say that, should I? So the regulars know there's loads of people, but maybe the new people are just like, oh yeah, she always gets 200 people watching her lessons. Right. Oh, here's Henry. Brilliant. All comments. Let's have a look. Hi, Lara. Yay, the summer holidays are over. All right. Fair enough. I was thinking, when you were saying that the Earth was bashed about early in its existence, you forgot to mention the entire planet that smashed into Earth and then merged and the debris formed the moon. Yes, I did. Well, I didn't forget. I didn't think that it was relevant, actually. If this lesson was about the moon, I would have mentioned that. But yes, you're right. It was about the size of Mars, wasn't it? But yeah, Earth had a hard time in the early days. But thank you for that. Oh, hello, Bella. Bella says, hello, Lara. I'm pumped for this lesson. I've just started bullet journaling and I'm now obsessed with calligraphy. Never a more homemade phrase spoken, I don't think. Amazing. You're bullet journaling and you're obsessed. Oh, look at this. Oh, I like how I know your full name now, because do you want to see Bella's bullet journaling? Look at that. That is some fancy calligraphy. Oh, I only printed the... Oh, look at my printout in colour. Love it. Right. Oops, that's just my plant. Okay, who else is here? What are you doing? Oh, Edmund's here. Edmund says that Methane Land is called Titan. And it's one of the moons of Saturn. Did I teach you anything this lesson, Edmund? Don't answer that hypothetical question. He is currently writing his own molecule book where he records the models he makes with his molecule kit, and the book includes this page on methane. Oh, come on, Edmund. Let's have a look at your methane page. Whoa! Oh, and chloroform. That's interesting. Okay, maybe I should start. I tell you what, we'll look at these pictures at the end. I'll say my hellos. Oh gosh, 142 people waiting. I know, right? And then there were more. And then I faffed on so much that there were less again. But you get the audience deserve. So if you're still watching this now, truly, you belong in the science lines. Oh, hello, Deacon. Loving learning about water and the planets. Big woes from the heavy particle experiment. Thank you. This is why I had to put all 3 activities in today, right? Just Bella going, blimey, it's going up. I know, it's been a really busy September. I think there's just a lot of people deciding to home educate. Hello, Violet. No, I was going to comment then about the British government. I'm not going to do that. Hello, Violet. Hello. Oh, it's Arthur. Oh, no, it's Aber. Hello, Aber. We are so happy that you're back. Oh, you're excited for the otter show. Excellent. The costume is so poor. How do you dress as an otter? I don't know. I'm very otter-shaped already. I don't know. I could web my... I'm not going to do that. Hello, Aurelia. I had a lovely summer, thank you. I hope that you had a lovely summer as well. Hello, Talitha and Simon. Hiya. Talitha and Simon are here. Oh, and Mark as well. Sorry, I forgot to say hello to Mark. That was rude. Oh, hello. Hello, Sophie. There's a lot of names here. Sophie, Emily, Katie, and Hannah. Hello, wonderful. They are so happy you are back and hope you had a nice summer. They wanted to show their cloud. Oh, we get a live cloud. All right. We'll have to watch that, I think, right now. Okay, let's have a look. Oh, I love it. This is a very theatrical, it's like a Victorian backdrop. Oh, nice. Oh, yes. It feels very kind of like wizardy. I like that. I didn't do a good enough job with my presentation. Talitha and Liliana, I totally forgot to say that. I should have said it to you right at the beginning of the lesson. I know you're watching. Hello, Talitha and Liliana. Hello. Hello. Hope you're okay. Hello. Good to see you. Not see you, that'd be weird, but you know what I mean. Who else have we got? Deck and Mick. Hello. Thank you. That was easy to say. Mick and Deck, Deck and Mick. Charlotte. Charlotte? Hello, Charlotte. Hi. And Charlotte's mum. Hello. All right, CJ and Oscar. Oh, hello, you two. Hi. Finally convinced Kiddo to give it a try. Brilliant. Finally convinced Kiddo. Kiddo's probably still not here. Kiddo probably hasn't sat through all this chatting. Kiddo, if you're still here because you've been convinced to give it a try and you're still here, brilliant, welcome. And if you're not still here, this is my, I don't even care. I don't care. Do what you want. Face. Never taken part before. Oh, the little ones are loving it. Oh, look at you. Oh, little ones. There you are. There you are, little ones. Watching it live on YouTube. Oh, that's so nice. Please say hello to Isla and Rona, who've just started home ed. You have just started home ed. And you love my magazines. You support me already. That is so, wow. Look at you just making so many good decisions recently. Thank you. That's really kind. Thank you so much for the support. I'd say like that makes all the difference, but that isn't enough. Like it literally pays my wages, which supports my entire household, which is like more than helpful. So thank you. Jackson is back. Hi, Jackson. Hello. Good morning, Imogen and Ophelia. Hello, you two. Hello. Hello from Alex. I love space. My favourite moon is Ganymede. No way. And my favourite planet is Earth. Ah, you got the word moat. Amazing. Oh, I hadn't even noticed you could make the word moat. Oh, that pleases me greatly. I always try and make it so that whatever answers you get, you will have some kind of interesting mystery words. That's nice. And that would have been a good word. Like not as obvious as moon, but still good. Yeah, next time. Oh, thank that. That was great. We definitely don't have dried basil all over the carpet now. Sorry, Lottie. Yeah, sorry. I mean, hopefully you don't have Italian mixed spice, mixed herbs all over your nice computer. All right, Zach and Aya. Hello, hello, hello. Aya and Zach. Hello. Thanks for the emoji. That's nice. Ziggy, star is 6. Ziggy Star, you cannot possibly still be watching. Are you now just having fun elsewhere with this in the background? Ziggy, thank you for coming, Ziggy. Thank you so much. It was so good of you to come. I hope that you enjoyed it. First time watching. This is so nice. There's so many new people. Jancy are here. Jancy is the cool band name of Jay and Daisy and Daniel if you accidentally say their names all together at one time, which definitely didn't happen. Good to be back. It's good to see you back. Hello, Callan. Hello. Matilda from Birmingham's here. Matilda speaks like that and loves it when I do the accent. It's more lively, isn't it? But I definitely is now. Birmingham. All right, Matilda. Hi. So offended. I'm just so rude. But accents are so fun to do badly. Hello, Dexy. OMG, I'm so happy that Lara's back. I missed you guys so much. Oh, that's so nice. Dexy, including everyone else in the missing. Hello, Amber. Just set up the cloud activity. Can't wait to see the cloud. Oh, that's nice. Right, I'm just going to quickly look at these little ones. Look at them. Maybe I shouldn't show. Oh, you can't see their faces. That was cleverly done. I think. Maybe I won't. I was going to show the little ones live on YouTube, but I won't. I don't like just because you put a picture of your kids on Facebook doesn't necessarily mean that you want me to show them on YouTube, so I won't. But anyway, I've loved seeing your little heads. Lara, can you find a bird call so I can do the bird call, please? Dexy, not this one, but there will be others. I'm sure there will be others. This is Odessa's, this is Odessa's first home ed online lesson. Your first ever. I'm so honoured. This is the first ever home ed. Your journey is just beginning. That's so exciting. Odessa, happy home ed day. That's so nice. Age 6. Wow, that is young. I hope that you're okay. Because that was a lot. That was a lot of information. Hello, Grace and Hope. All right, you two. Oh, that's nice. Look, Bella is saying, welcome to all the newbies. You are now officially in the Science Alliance. You are. I don't really have anything to do with anything on Theatre of Science, and I didn't make up the name Science Alliance. Someone a long time ago did. So you're all now in the Science Alliance. If you watch my lessons, you're in the Science Alliance. Grace and Hope say Earth has oceans to surf on. It does. I had a surfing lesson once. I did not have a second surfing lesson. Not naturally good at surfing. Hello, Gilbert. I'm not good at working on things that I'm not naturally good at. Gilbert, good to see you. not see you, but you know what I mean. Oliver, hello, Oliver. Hello, Ed. I knew it was you because you put a picture of a cat doing something. I like that one, thanks. Oh, so excited, racing already. Rosie, was that you? I was like flying around, trying to dry my hair, failed miserably. And you were waiting, and I was feeling all of the pressure in a good way. Hello, Henry. Great first lesson. Love the cloud experiment. Oh, thanks very much. I'm sorry, it's taken me ages, isn't it, to get through the hellos. It's very tedious if you said hello a long time ago. Hello, Ivy. Whoa, it's Ivy's birthday this week. Enjoying reading the mould issue of the magazine. Thank you so much for your support, Ivy. Sadly, it wasn't possible to show you our open sunflower. Oh, good, but your sunflower open. That's good. Ivy, we've got a cloud and sleepy Jasper. Maybe Jasper's less sleepy now. Let's have a look at this cloud. Come on. Oh, that is nice. Wow, that's very good. That's such a nice activity. Love this activity. Right, come on, because I've got to set up my Otto story as well. Noah and Tobias, hello. They joined you for physics yesterday. Oh, that's great. Well, that's the biggest compliment. It's not the new people watching for the first time, it's them watching for the second time. Oh, that's lovely. Super enjoyable lessons. Thank you, Noah and Tobias. Thanks a lot, dudes. Hello, Lara. The Martin children loved the lesson. It was very spacey and oceany, wasn't it? You will know when you watch more lessons that I just turn everything into physics because I love it. Your cloud was cool. Good. Also a good pun. Hello, Martin children. Hello, Hannah and Lucas. We didn't know that we could post messages here until now. Well, you've not missed anything. You've just missed me chatting on to everyone else, haven't you? Hey, Sebastian and Humphrey. Hello. My mum said your hair looks nice. Thanks. I didn't have time to dry it, but yeah, thanks. A regular person once joked that my first week of lessons, it's sort of like a first date and I always make more effort. And that is absolutely true. It would be quite funny to look at the first lesson I do of a module and the last lesson I do of a module where it's just like stuffed into 5-day-old pigtails. So thanks. Thanks, Sebastian's mum. Appreciate that. The reason the oceans left Mars is because the atmosphere was thinner. So the solar wind blew them away. Love, Sebastian. Thank you, Sebastian. Thank you. Jacob posting me a picture of a seal. That was confusing. What are you doing? Why are you messing with my head in this way? I'm about to do a lesson about otters. That is a good gift, though. Oh, excellent. There is another cloud. Brilliant. Rose and Pearl. Hello, Rose and Pearl. Bye, Rose and Pearl. Thank you for coming. Ed, all right, that's another good picture. Hannah and Freya, hello. Our most easily available hot water is tea. Have you made a tea cloud? Brilliant. Hannah wants to show you the drawing she made with the burnt match. That is another, I feel, just very homemade thing to do. Just grab things around and be creative with them. Why the waste? Look at this. Hannah, that is a stunning picture of a horse. I used to love drawing pictures of horses and they were nowhere near as good as that. That is very good. I love that. It looks like it's moving. Look at the ears. That's very pleasing. I can't believe you did that with a match. Like in ye olden ancient times. Right. We've got to the end of the comments. Oh, Shuki, Anaza, and Eunice and Salomon Musa are here. Hello. Hello, you lot. Hello, Callan. Hello, Jacob. Let's have a look at Ed's. Look at this. This is Ed's molecule book. So that's methane. Thank you. Yeah, exactly. Lakes of methane on Titan. Can life use it to exist? We don't know, but maybe we will soon. Let's hope. And there's chloroform. Didn't know that's what chloroform looked like. Interesting. The deadly gas. Chloroform, everyone. Right. I'll refresh because I know it's well annoying when you just found out that you could put comments on Facebook so that I could say hello to you. And then I just go, okay, right, thanks, bye, and click it away. So I won't do that. Thank you so much to everyone who has signed up to support me on Ko-fi, by the way. As I've been teaching, it is the best feeling ever. It's so cool. It's like busking in the street and someone comes over and puts a quid in your hat. It's like, you didn't have to do that and you did. So thank you. I've been far too much of a pro to mention it every time it happens because I don't want to slow this bit down even more. But it's hugely appreciated. Thank you. All right. I'll go to newest. Facebook's sometimes a little bit weird about showing me the comments in order. So like if you've commented on another post, I might not see it straight away. I'm sorry, but I'll go to newest comments and see if anyone else has said hello. Oh, look, Sasha and Emily are here. Just to say, we think another reason water is important on life. Yes, this is true. I didn't go into this. Yes. Ice is less dense than water, so it floats. That is absolutely true. Yeah, very good. So when there's an ice, yes, it's true. That's a load of stuff that we don't really have time to talk about. Yes, water's very unusual, isn't it? Because when water gets cold, it actually is, it's bigger as a solid than it is as a liquid. So liquid water is like, takes up a small amount of space. When it freezes, it gets bigger, which means that it floats. Yes, you're right. If water didn't do that, then every time there was an ice age or stuff got frozen, the ice on the top of the ocean would sink to the bottom of the ocean and crush and kill everything and wouldn't be able to breathe. So yes, you're right. That's excellent knowledge. Also a nice gif of a penguin as well. Thank you. Hannah and Freya are still here and they're doing the tea cloud and there's the picture of a horse. Is that the last one though? Oh no, here we are. Callie and Corey's first lesson. Ah, that is very nice. Hello. Thank you for coming. If you're still here. If you're not still here, you're forgiven because this bit has gone on for a long time and I'm sorry. But anyway, Callie and Corey, thank you and goodbye. And also, hello. Oh, Dexter and Daisy are here. New to the lessons. Have had a fab time. Learning about water. Oh, that's really nice. All right, Daisy and Dexter and Daisy. Hello. Hello. And Esme and Dougie are here. Well, loads of new people for the new lesson. Hello. This is awesome. Hello, Jack and Mum. First time watching. Brilliant. Hello. Thanks. Amazing. And then it's Dexy going, hi, Silence and London and OMG. I'm so happy that I was back. I miss you guys so much. That's so nice. And then Ziggy Star again. Okay, right. So I think we're at the beginning. I'm really sorry if you've, there's Lottie again and Zach and Aya. If you said hello to me and I didn't see it, then I'm very sorry. But we've only got 25 minutes now. For you to have a little screen break, go and have a run around, I don't know, play in the rain, whatever you home educators do when you're not hanging out with me. And I will go and set up my Lego story show and prepare to teach anyone who wants to come about otters. So thank you so much for the comments and for all the likes and the subscribing and the follows. Thank you for your actual cash money. That means everything. And I will see you all, I'll see some of you in 24 minutes for learning about otters here. And I will see some of you next week for learning more about the oceans.